objectives is comparing linear and quadratic graphs. To start off, we need to know what's the difference between linear equations and quadratic equations. So a linear equation produces a straight line. When you graph it, each value of x produces one and only one value of y. Next, when you graph a quadratic equation, you produce a parabola that begins at a single point called the vertex and extends upward or downwards in the y direction. The relationship for any given values of y except the y value of the vertex has two values of x. Here's my vertex, and any other point from that one on, there will be two x value or one on each side of the vertex. Example number 1 says in 1980, a brand new Mercedes with a 300 diesel engine cost $23,000. The price went up each year as seen in the follow data table. Please answer the question. Example number 1 is very similar to what we have done before. That's why I want you guys to give it a try. Double check the answer and you guys understand it, everything. I would like to go over real quick with you guys. What's the explanatory variable? That is the x value. Okay, that's the x value right here, variable right here. Then the next one, responsive variable, that's the y, which is the price. Then what pattern do you see in the collected data? Well, the collected data, if you check between 2300 and 23700 and 24400 and 700 increasing every single year. So that's why I can say for letter C, each year the price of the car goes up by $700. And D, fill in the box with the number that continue the pattern. So since I know it's going up by $700 a year, I took the 26,500 and added another 7,000, and that gives me $27,200. So that's letter D. E, are those linear data linearly related data? Why or why not? Because they're going up the same constant variable, constant number. Yes, the data is going to be the same. Yes, the data are linearly related. Don't forget, linearly means a straight line. The reason is linearly related because every year the price goes up the same value. Again, $700 even if you want to put it down. Letter F, write an equation for the price as a function of the year since 1980. Now, remember, writing an equation, you need to have the y-intercept. And y-intercept is when x equals 0. So therefore, right here, that's your y-intercept because x equals 0. And then so that's going to be 23,000. That's your y-intercept. Then you have the 700x. 700x means that every single year goes up by $700. And for some of you guys who has done the project related to the cars, you notice the Prius goes up the same amount, and same thing is the Camaro. G, what does the slope mean in the context of this problem? And you should know the slope means the price of the car goes up $700 per year, and that's the slope, something per something. There is your example number 1. This is a linear, and we're going to compare things like that with a quadratic equation. Please try to fill out for example number 2. For example number 2, below is the data for the money spent in the U.S. on postal technology beginning in 1970. So there's the graph. I would like to go through it with you guys so you understand. Letter A says what's explanatory variable, and so that is going to be again x. And then what the second question says what is response variable, and that's your y right here. That's your response variable. And then what patterns do you see in the collected data? Every year it goes up faster the $1 billion was made. So if you look at the data, this is how I come to the conclusion. You go up by 1 year, you go up by 1 year, you go up by 1 year. But if you look at here, it's really more than just 1. Okay, so let me write this out so you can see. If I go up by 1, those are the patterns. But if you go up here, that's going to be 0.5, and the next one is going to be 1.5, and the next one is going to be 2.5, and the next one is 3.5, and so that's how I arrive 4.5, and the next one on my blocks for the blanks is going to be plus 5.5. All right, and that is how I got number 19. This is a little bit out of step, but that's where it comes from. So the next thing is C, the pattern you see in this collected data every year goes up on the X, the faster the, every year goes up, the faster the $1 billion was made. Or you can say the Y value goes up faster each year based on the X value. All those things are totally okay, but I prefer to use the units, which is in this case X is year and Y is $1 billion. All right. D. Are those linearly related? No, it's not linear related. Now, here's something that's new. Because the second degree difference is the same for the Y value. Now, what does that mean? I want you to go back up here. Look at the numbers. If you see the difference on the Y value. So here's the Y value. Okay, that's your Y. Now, the interesting thing is, did you guys notice that I already take the difference between 1 and 1.5, and that's 0.5, and 1.5 and 3 is 1.5. But if you take the difference of the difference again, that means between 0.5 and 1.5, that's 1. 1.5 and 2.5, that's also 1. And so forth. And that tells you this equation or this formula, once you start writing it, is a quadratic equation because it's the second degrees. By finding the difference once, it's a linear if it just goes up by the same number every time. But since this is going up by 1 each time, after the second difference, it's going to be a quadratic equation. So now what you're going to do is it linear? No, it's not linear, because linear, you only have to worry about it goes up the same thing, like example number 1, going up by $700 each time. If it's a linear, the difference will be right away. And if it's quadratic, the difference will be the second set of difference you find, and they should be the same, and that's your hint. Okay, and then after that, we know we've plotted data. You see me plot the data right here. I just did it a little bit bigger. I go 4 boxes on the bottom, 2 boxes on the side. And then what type of the graph is plotted? It's quadratic because I had to find 2 sets difference of the Y value to get the same thing. So that's a quadratic equation. Example number 3, we should be able to look at the equations and tell me which one is quadratic. In this case, all of them is quadratic. The reason for that is because they all have a square right here as your equation. So this is quadratic. Example number 4, for f of x equals negative x squared plus 2x minus 1 and g of x equals negative 3x plus 10. Find the following. Just remember, there's your hint. Remember, first put parentheses around each variable when you substitute the value for the variables. And then if you look at example, if you look at letter A, that tells you which equation to pick. This is F, so you are going up to here and pick up the F and then just plug in. And I believe we've done this before. So please finish your A through D and we'll compare the answer. So answer for 4A is negative 16, 4B is 4, 4C is 19, 4D is negative 1. And notice I put in the value in parentheses every single time, replacing the letter. So make sure you do that so you don't screw up on the signs and the numbers. For example number 5, annual consumption of bottled water was being increased since 1990. Use the given data to answer the following. Identify the explanatory variable and responses variable. So in this problem, year since 1990 will be your explanatory, that's your X. And then annual bottled water consumption, that's going to be your Y. Also, another thing is they gave you a little space and they give you a hint. Year since 1990. So 1990 is going to be 0 and 5. 1995 will be 5, and then 2000 will be 10, and then 2005 is going to be 15, and 2010 is going to be 20. Now make sure you understand that we do that a lot, year since when, okay? So make sure you definitely do that chart. Now using technology to graph the table, I would like you guys to go back and then refresh your memory on list and entering the years as 0, 5, 10, 15, 20 under your list 1, and then you do list and you put your annual bottle consumption as list 2. So I'm going to put that right there and go ahead, answer the rest of the question except letter D, and I'm going to show you how to do that. What you have is you are going to go to stat, and then we are going to edit. We're going to put in the first list, so that's number 1, and then I'm going to clear the list. So go up to L1 and say clear and press enter. And then that will clear up. And then you're going to go up to list 2 and press enter. Now this can be changed, depends on the way you want to do things. And then I'm going to go ahead, enter everything. So that's going to be 0, enter, and so forth. Okay, so I'm going to pause this and you guys can go on finish it. Okay, if you notice, I put the list in 1 and 2. And then we're going to double check the numbers and press enter. Okay, so second quit. Now make sure that your stat plot is turned on. Okay, so right here is off, so I want to turn it on. Go down there, 1, and then press enter. And then since it's off, you see that? We're going to turn it back on over here. And then we want a little scatter plot, which is 1. And the number I want to pick out is list 1, list 2. And then I'm going to use a little square. So then after that, you're going to go to zoom, and you're going to go to zoom stat. Okay, and then we'll graph. Using the same number, this time we are going to clear. This time we are going to do the quadratic regression. So go to the same thing because we have the numbers in there. Go to stat, go to calculate, go to quadratic, which is number 5 now. Press enter, quadratic regression, press enter. Now if you notice, there's A, B, and C, and this is a quadratic formula. So now jot that down. Example number 7. Find x so the area are equal. An area formula you should know that's length times width. So the area for the square is going to be times x, and that's equal to x squared. Then the other one is going to be 2x area 2x plus 8 times 1. In this case, that's just going to be 2x plus 8. Now since they tell you they are equal to each other, so to solve this is going to be x squared is equal to 2x plus 8. And to solve this is going to be minus 2x on both sides. And that's x squared minus 2x equals 8. And then minus 8 on both sides. X squared minus 2x minus a equals 0. Now you have to factor. And when you factor, what you're going to do is you are going to do the 1 and 1, and then 4 and 2. You can have 1 and 8 or 4 and 2. And then if you do negative 4, positive 2, you will have x minus 4 and x plus 2 equals 0. And go ahead, solve it. Now the problem is if you got 2 answers, and because this is an area can never have a negative number, you are not allowed to use x equals negative 2. So for your answer, the length of the side is 4 for the ones on the left hand side, and then for the other one, the length is going to be 2 times 4 plus 8. So since I did not ask for it, you can just say find x. So therefore, the only answer you are allowed to have is x equals 4. So if you put down both answers at the very end, you will get it wrong. All right. So that's example number 7.